Hi, welcome back to Math with Mitchell, and today we're going to discuss a little bit of trigonometry and different, or specifically sine and cosine, and how that looks on a graph and how we would use it in like a problem. So first, let's discuss sine. So normally at the end of Algebra 2, we discussed how sine can be related on a unit circle, which I have down here, and how sine is the y component of the unit circle. So sine of, let's say, 30 degrees or pi over 6 is equal to 1/2, and that these values relate, radians and degrees to sine and cosine. So you also may remember that we discussed that sine is going to be your equal to your opposite angle or opposite leg over your hypotenuse in a triangle. You sort of won't use this. You won't use this too much in pre-calculus and calculus. We're mostly going to use the unit circle relation. So that's what we're sort of going to show. That's what I'm going to show you today, is how you can get from the unit circle to the graph, and then what we would use the graph for. So first off, in the previous video, we just covered briefly what sine and cosine is. So you roughly know that it's going to be a parabolic or a wave that just keeps on repeating forever. So hopefully I'll show you here is that it directly relates to the unit circle. So let's start plotting points. So if you look at sine of 0 degrees or sine of 0, so I have radians on the x and values on the y. That is going to be 0. So you know that this first point is going to be 0. And then sine of 45. So this is let me clarify this. This is sine x equals f of x. So what we're doing is just inputting values, and we're going to graph them and show that the function of sine directly relates to the graph. Or if you plug in values from the unit circle, the values that the unit circle gives you create this graph, this wave. So next of sine of 2 pi, or let's do sine of pi over 4, which would be 45 degrees. So that's going to be roughly, square root of 2 over 2, which is going to be roughly right here. It's a rough estimate. And next, your pi over 2, which is going to be 1. You can see right here. And then next, let's do 3 pi over 4, which is going to be roughly right here. Similar value. And then at pi, it's 0 again, because sine is the y component. Let's see if I can scroll down here a little bit. Okay, so a little bit more. And then in between, so 5 pi over 4, it's going to be roughly right there. And then at 3 pi over 2, it's going to be -1. And then again, it's going to be square root of 2 over 2. And then back at 0. So we're going to get this wave-looking function. The drawing's not too great, but you're going to get this wave-looking function like this in either direction. That should go down to -1 up to 0. So you're going to get this wave-looking function. Obviously, my drawing is not too great, but this wave function is defined by the values that are in the unit circle, which is kind of cool relationship that you'll find that will be very useful in the future. Now, quickly, I want to go over some. So quickly, remember back in Algebra 2 when you were sort of manipulating polynomials, where if you have something like x minus 1 plus 2, the graph of x was shifted over to the right 1 and up 2. So that's very similar to sine. So if we have sine of x minus 1 plus 2, it's a little different, but or it's almost the same. The graph, as you see here, shifted up 2, and it's shifted to the right 1. So you can use sort of the center point here and shift it over. Now, we're going to get into some complicated things like periods, which is how wide or how many times the graph goes through or how short the wavelength is within a certain period, like 2 pi. And then also amplitude, which is when you add 2 or you multiply sine by 2. So we'll cover a little bit of that here, but you'll get more practice at it later. So say if I do multiply it by 2, then this graph, instead of going up to 1, it's going to actually go up to 2 and negative 2 in both directions. So it's going to become higher, if that makes sense, or higher, or it's going to cover more distance. You can, if you have a graphing calculator, this is really cool to plug in and manipulate and see the difference between 2 sine of x and 3 sine of x or something like that, or just sine of x. And then, like I said, the period, if x is multiplied or divided by something, so like say divide by 4, then you actually, it's dividing x by 4, so then it's actually going to have it's going to change its period. So that means if it's divided by 4, it's going to have a longer period. So it may only have like 1 hump instead of 2 before x pi, or before 2 pi. So it changes how long, the frequency of it, you can say. The frequency will change. So those are sort of the main components that you can manipulate sine with. Now sine squared is something to consider too. So what do you think sine squared would be? Well, sine squared is just going to be the square of this term. So you can sort of almost imagine that all the terms are going to be positive. We'll discuss that a little bit later too, is when you square it, or when you get a sine squared or sine cubed, change the graph a little bit, but also you got to remember your properties where sine squared, it's going to be positive. You're not going to get a negative value there. So that's sine. Now cosine is very similar, so I'm going to go through it a little bit faster. It's basically, if you do the values like we did for sine, it's going to be something that looks like this. Down like this, down like that. So it's shifted. It's sine shifted over by 2 pi, which is kind of cool to visualize there. So like sine, you can still manipulate it by having like 2 cosine x negative 1 plus 2, which I would shift this cosine graph up to over to the right 1, and the amplitude would turn into 2. So these would turn into 2. Now, also the big thing with this is that the x is in radians, or the x coordinate is in radians. So these numbers will be in radians. Your answer will be in radians, or no, your x values will be in radians, and your answer is just going to be the y value here. Its units don't quite apply, but you got to be careful because shifting over 1 is going to be shifting over 1 radian, or your 1 pi value, because you mark them as in pi. Just be careful. It's not like 1 pi shift over. I mean, sometimes you'll say it's shifted over pi, which then it is shifted over 1 pi. When you're just shifting it over by 1, it's different. And something to be careful about. But that's basically sine and cosine. This is sort of how you'll be looking at them, the two functions, throughout pre-calculus and calculus, and manipulating them and using them in equations to solve, because they have some pretty unique properties.